Zeta Ophiuchi is a star also known as HD 149757 or HR 6175 is with a complicated past, having likely been ejected from its birthplace by a powerful stellar explosion. A new look by NASA's Chandra X-ray observatory helps tell more of the story of this runaway star. If it weren't surrounded by so much dust, it would be one of the brightest stars in the sky and appear blue to the eye. Located about 440 light-years from Earth, Zeta Ophiuchi is a hot star that is 20 times more massive than the Sun. Zeta Ophiuchi was likely once part of a binary system with an even more massive companion. Previous observations have provided evidence that Zeta Ophiuchi was once in close orbit with another star, when the companion exploded as a supernova, blasting away most of its mass, before being ejected at about 100,000 miles per hour when this companion was destroyed in a supernova explosion over 1 million years ago. Zeta Ophiuchi was suddenly freed from its partner's pull and shot away like a bullet moving 161,000 kilometers per hour. Previously released infrared data from NASA's Spitzer Space Telescope reveals a spectacular shock wave that was formed by matter blowing away from the star's surface and slamming into gas in its path. Data from Chandra shows a bubble of X-ray emission located around the star, produced by gas that has been heated by the effects of the shock wave to tens of millions of degrees. Researchers has constructed the first detailed computer models of the shock wave. They have begun testing whether the models can explain the data obtained at different wavelengths, including X-ray, optical, infrared and radio observations. All three of the different computer models predict fainter X-ray emission than observed. The bubble of X-ray emission is brightest near the star, whereas two of the three computer models predict the X-ray emission should be brighter near the shock wave. In the future, these researchers plan to test more complicated models with additional physics, including the effects of turbulence and particle acceleration, to see whether the agreement with X-ray data will improve.